Let's review some functions and transformations and composition functions. Let's just review a bunch of junk, okay? First off, given two functions, f and g, we want to find f plus g of -5. All right, we want to find, so that's like saying f of -5 plus g of -5. I'm not distributing, I'm just rewriting it. That's the notation. I'm not distributing anything. That's just the notation. Now f of -5, remember what that means? You're going to plug into f, you're going to plug, everywhere there's an x, you're going to plug a -5. So that x becomes -5. And -5 minus 4 is -9. That's -9. Now we're going to add that to g of -5. So come over to g. Everywhere there's an x, you put a -5. Minus 3. -5 minus 3 is -8. -9 plus a -8 is a -17. So f plus g of -5 is equal to -17. There's going to be some other types of questions where there isn't a value here. You're just going to find the new function where you're subtracting the two functions away from each other. So it's still the same idea. It can be rewritten as this, and f of x is this whole piece. Now we're subtracting it away from all of g of x, so don't forget to put this set of parentheses in here because you're subtracting the whole function. All right, if you don't put that parentheses in right there, you're going to say minus 8x and not minus 5. All right, so the idea is you got to put those in parentheses because you're subtracting the whole function. If you don't do this, you'll get it wrong. So now, remember what happens when there's a negative in front of parentheses? It's like distributing a -1. And then we combine our like terms. 5 minus 8. I'm just putting those two numbers together, get -3. -3 and a +5 would go together to give you a +2. And there's your new function. If you were to subtract those guys away from each other. Division. Let's divide them from each other. So this is the same thing as saying f of x divided by g of x. So f of x is on top. G of x is on bottom. That's it. I mean, sometimes they want you to simplify this stuff out, but I mean that's the basics of it. It wouldn't simplify. If you did simplify it, you could pull an x out of the top, and then you could factor the bottom. Factors of 14 that would subtract to give you 5. That would be 7 and 2. And there's no way to get the same thing on top and bottom. So that's it. So this is your answer, or this one, doesn't matter. They're both the same thing. Let's add them together. F of x plus g of x. And all I'm doing is, that's the notation. This is the same as saying this. 9 minus 5x is f of x plus -3x plus 5. And when it was subtraction, I used the parentheses, but it doesn't matter when you add. It matters when you subtract. I'll go ahead and put parentheses anyways. Because if you distribute a +1, it's like nothing ever happened anyways. So 9 minus 5x minus 3x plus 5. And then these two guys will go together, give you -8x. These two guys will go together, give you a 14. There's your new function. Now this is a little bit different. This is what we call a composite function. It works a little bit differently, and it's rewritten as not times. It's rewritten as f of g of. That's how it's rewritten, and we're doing this with a 2. So you're going to find g of 2 first, and that value goes into f. So this goes into g, that value goes into f. So one feeds the other. So g of 2 in this case would be -7 times 2 squared minus 5 times 2 plus 7. So g of 2 is -7 times 4 minus 10 plus 7. That'd be what, 38, negative 38 plus 7, negative 31. So we're going to take and find, that's g of 2 is negative 31, so we're finding f of negative 31 now. So we're going to plug that into f now. So 4 30s would be 120, negative 124, plus 5 would be negative 119. There you go, negative 119. That is our composite function. That's what our value is. We took one value, we put the 2 in to g, got that answer, plugged it into f. That's what a composite function does. One function feeds the other. So this is when you have a value here. There'll also be times when you're not given a value, you just want to find it where there's an x here. Sort of like what we did before, you just simplify, you plug stuff in and simplify. So it's f of g of x is what we're finding. So g of x is this guy. Alright, now we're going to plug that into f right there. So 6 parentheses 4x minus 1, that's what x is, plus 5. And we simplify a bit, we'll distribute. And these two guys will go together. There's your composite function. This is going to be a little bit different because in this case it was f composed of g of x. Here it's g composed of f of x. And the order is different. I mean, it matters what order these letters are in. It matters. So this is the same thing as saying g of f of x. F of x is 5. Oh, shoot. I can't read. F of x is negative 3x plus 2. So I'll replace that with negative 3x plus 2. Now this guy goes in right there into g. So we distribute. Alright, we distributed. And then these two guys go together. There you go. There's your composite function. Every now and then you're given a question where it says find f and g such that h is the composite of f and g. F composed of g of x. And they give you function h. So what would f and g be whenever you did this composite function like we did just a second ago to get this? That's kind of the idea here. What would f and g have to be to get this? And it's f composed of g of x. So the idea is that g goes into f. G goes into f. So I'm gonna pick something. I'm gonna pull this bottom off of here and call that g. So that's the value that's going to go in. So since I pulled it off of there, there it is. It's like I'm pulling that off of there. It's like it never existed. That's what my g value is. So f needs to be something like this, but it needs to be something needs to be there for a placeholder so g knows where to go. So that's what I'm going to do. I'm going to make my f this. So now what you get is you get this guy goes into f right there, and then you're back to where you started with. Let me put that back where what it was. And you'll wind up with h, which is the original. So you kind of just pick a piece off, make it the first function, and then whatever you picked off of there, that's going to be you put an x there, and that's going to be your f. That's kind of the idea. And there's not one way of doing this that's correct. You could have just picked off the well, here's what you can't do. You can't say that one of them is x, and then the other one is the original. So you're not supposed to do that because that's kind of trivial. You're not supposed to do that, but there's more than one way to do these questions. All right, and there's more than one way to do them, and they're right. There's composite functions. So here we're going to talk about transformations. So how can the graph of f of x equals negative square root of x plus 7, notice that it's all under the radical, be obtained from the graph of y equals square root of x. So the y equals the square root of x looks like this. And this is the parent function. It's the parent of this, right? This guy right here is going to look like this somehow or another. And the differences between it, there's a +7 and there's a minus out front. And both of those will do a specific thing. If you add or subtract, let me put it this way. If you think about it as order of operations, if you were to plug a value in for x, say you plug a 2 in. Say you plug a 2 in for x. Suppose. Okay, I'm just kind of talking here, okay? It's not what you do every time. You don't plug a 2 in every time. Just imagine a moment that you're plugging a 2 in for x. What's the very first thing order of operations says to do? Order of operations say that you must add 7 first. If the very first thing you do is add or subtract, if that's the very first thing the order of operations says to do, that's going to be a horizontal shift. And that's what you do first whenever you're graphing these. You do your horizontal shift first. And add, you would think would be to the right, but it's not. It's to the left. And if it's subtract, you would think would be to the left, but it's not. It's to the right. It's opposite what you think it would do. And what's happening is it's compensating for adding or subtracting to get to this graph here. That's kind of the idea behind it. So this +7 is the very first thing you do. It's a horizontal shift. Not to the left. Not to the left. I'm sorry, not to the right 7. It's to the left 7. So you need to move the graph y equals the square root of x left 7 units. So it looked like this. 1, 2, 3, 4, 5, 6, 7. Now it looked like that. You take that same curve and you move it to the left 7. Okay, if you have a negative out here on the outside of the function, as in all you did was come out here to this dude and just put a negative on the outside. Okay, right here on the front. You just slapped a negative on the front. If you slap a negative on the front, then you've done a reflection. Reflections are done second. If it's in front of the function, then it's going to be an x-axis reflection. If the negative is on the x, that's a y-axis reflection. So what do I mean by that? I mean that see how the negative's out front? That's going to be the x-axis. See how the negative's on the x? That's a y-axis reflection. So that's the differences. That's what I'm talking about there. All right. So since this has a negative out front, it's reflected over the x-axis. So it reflects over the x-axis. So the actual graph looks like this. So how can you obtain the graph? You need to move the graph left 7 units and reflect the x-axis. Reflect the x-axis. So let's try another one. How can the graph f of x equals x minus 10 squared minus 4 be obtained from the graph of y equals x squared? Well, the y equals x squared is that guy. It's a parabola. So we think about this for a second. Is there any horizontal shifting? Order of operations. If I plug a 1 in or a 2 or a 3 or 4, whatever, if I plug a value in for x, order of operations says I have to subtract 10 first. That's a horizontal shift then. That means it's a horizontal shift. Minus 10 you would think would be to the left, negative, but remember, it's backwards. It's not how it works. It's to the right. So we're going to shift this dude to the, it can be attained by shifting y equals x squared to the right 10 units. Is there any reflections? There's nothing in front. There's no negative in the front. There's not a negative in front of the x, so there's no reflections. Now, the very last, so if you were to plug a value in for x, you would subtract 10, then you would square it, then the very last thing you would do is subtract 4. If it's the very last thing you do in order of operations, then that is a vertical shift. And negative means down, plus means up. So this means down 4. So it's down 4 units. There you go. Any questions, feel free to ask.